Hello everyone, welcome back. Today we're looking at another geometry problem. So here's the setup. We have a right triangle with side lengths 3, 4, and 5. Inside that triangle, there's a square placed right at the right angle. The problem asks to find the area of that square. Before we go any further, I definitely suggest pausing the video and giving this a shot on your own. Even getting partway there is worth it because the key idea is more about geometry than algebra. All right, let's walk through it together. We'll start by labeling the triangle carefully. Point A is the right angle. The segment from A to D has length 3. The segment from A to E has length 4, and because of that, the hypotenuse from D to E has length 5. At this point, everything hinges on similarity. First, we drop a perpendicular from point A straight down to the hypotenuse. Let's call the point M. This creates two smaller right triangles inside the original one, and this is a classic result. Both of those smaller triangles are similar to the big triangle. That similarity gives us very concrete information. Because triangle ADM is similar to triangle ADE, the ratios of corresponding sides must match. In other words, the way AD compares to DE is the same way DM compares to AD, and also the same way AM compares to AE. This lets us compute exact lengths. The height AM turns out to be 12 over 5. The hypotenuse is split so that DM is 9 over 5 and ME is 16 over 5. Let's call the side length of the square S. Along the base of the triangle, the square breaks the hypotenuse into 3 pieces. The left piece we'll call X, then comes the square itself with length S, and the remaining piece on the right we'll call Y. Now, look at the small triangle formed by points D, F, and H, and compare it to the larger triangle formed by points D, M, and A. These two triangles are similar. They share the same angles, and their sides line up proportionally. Because of that similarity, the ratio of the square's side S to the base segment X must equal the ratio of AM to DM. So let's slow down for a second. We're matching corresponding sides of similar triangles, square height to square base on one triangle, altitude to base segment on the other. When we substitute the values for AM and DM, that ratio becomes 4 over 3. Solving this gives X equals 3/4 of S. Now, we repeat the same reasoning on the right side. Look at triangle EGK formed by the square and compare it to triangle EMA. Again, these two triangles are similar. Same angles, same orientation, just different sizes. This time, the ratio of S to Y equals the ratio of AM to ME. Substituting the values gives 3 over 4, which tells us that Y equals 4/3 of S. At this point, everything is expressed in terms of S, which is exactly what we want. The entire base of the triangle has length 5, and that base is made up of X plus S plus Y. Substituting our expressions for X and Y gives 5 equals 3/4 S plus 4/3 S. Combine those terms, and you get S times 37 over 12 equals 5. Solving for S gives S equals 60 over 37. And now we're basically done. The area of the square is just S squared. Squaring 60 over 37 gives 3600 over 1369. That's the final answer. If you enjoyed this problem, and especially the similarity ideas behind it, make sure to like the video, leave a comment, and subscribe for more geometry problems. Thanks for watching, and I'll see you in the next one.